Okay, our third lesson for the unit, it's all about zap. Or maybe it's not zap, maybe it's pizza. Oh yeah, it's all about pizza. Okay. So let's see what is shaking with this wonderful lesson 3. Our learning targets. Aha. We're going to be able to find the area of a circle, which you've probably done before. But we'll also be finding the area of a sector. So if you want to think about the pizza being the entire circle, one slice of pizza could be a sector. So how do we find the area of a circle? Well, let's start out with a circle. Ooh, or even better, pepperoni and mushroom pizza. Yeah. What are we going to do with this pepperoni and mushroom pizza? Well, we can slice it. And then after we slice it, we can arrange the slices into a rectangle. So there they are as a rectangle. Not the world's best rectangle. But if I could slice the pizza into thinner and thinner pieces, it would more and more look like a rectangle. The width of the rectangle would become closer and closer to the radius of the circle, right? Each slice of pizza, the length would be the radius of that circle. And the length of the rectangle would become closer and closer to half the circumference, right? Because half of the crusts are on each of the lengths. Okay, so my slicing up pizza maybe wasn't the best of the bunch, so let's go steal an image from the internet. Right, so if we have a circle, and we know that circumference is 2 times pi times the radius, if I could slice it up, rearrange the slices into a rectangle. Now again, that does not look like a rectangle, but if I can make the slices thin enough, it become closer and closer and closer to a rectangle. And of course, since half of the crust is on the length of that rectangle, it's half of the circumference, also known as pi times r. So if the rectangle is length times width, we're looking at the length is pi times r, the width is r, area has to be pi r squared. If you're thinking that looks pretty similar to the circumference, it's just that the 2 is out in front instead of an exponent when you're looking at the circumference versus the area. Come back in calculus and you'll find out why that is happening. All right? But for the time being, you just got to kind of take our word that the circumference is 2 times pi times the radius, and that the area has to be pi times the radius squared. Okay, so let's play with some circles. Let's find an exact answer and then also find a decimal approximation. So find the area of a circle with a radius of 5 inches. Well, if the radius is 5, that has to be pi times 5 squared. 5 times 5 is 25. There's an exact answer, 25 pi. All right? Or more specifically, 25 pi square inches. Notice it's not just inches because it's area, it's now square inches. Or if I want to grab a calculator, 25 times pi, approximately 78.54 square inches. Okay, so again, let's find an exact answer and also a decimal approximation. Let's find the area of the circle. Okay, well, I know area is pi r squared. And of course the radius is, what is the radius? It's not 3, is it? The diameter is twice the radius. So if that diameter is 3, 3 over 2 is the radius. Notice I'm going to leave it as 3 over 2 instead of 1.5. I really don't want to try to do 1.5 squared in my head, especially if I want an exact answer. Right? I think in my head I can do 3 times 3 is 9, and 2 times 2 is 4, and I can get an exact answer for the area without touching a calculator, and it's a real nice looking answer, right? No decimals. So if I want an exact answer, 9 pi over 4, was that 3 feet, 3 miles, 3 inches? I don't know. So the diameter was 3 units, so the area will be in square units. And then of course if I can grab a calculator, I can do 9 times pi, divide that answer by 4. Notice when I use a calculator, I don't round off the first answer and then divide by 4. I actually divide by 4 and do all the rounding when I'm all done. Usually doesn't make a big difference, but it might make a tiny, tiny difference in that last decimal point. Okay, let's take another look at an example of a circle. Let's find the diameter if we know the area. Right. So when I see that ft with the exponent of 2, I'm basically saying, hey, square feet. Right. Area is 48 square feet. Well, if the area is pi r squared, I know the area is 48. Let's divide each side by pi. 48 over pi is the radius squared. Got to take the square root. And of course, this is the difference between geometry and algebra. If we were just solving an equation in algebra, we would have to put the plus or minus symbol in front. However, because we know in geometry that the radius must have a positive value, I don't need to put the plus or minus in front there. We'll just take the positive principal square root. And so, of course, I come up with about 3.91, and I can congratulate myself and do jumping jacks because I've got the answer of 3.91 for the radius. It always pays to read the directions. I'm not trying to find the radius. I want the diameter. I need to double the radius to come up with the diameter. And again, I would have done that with the calculator using the full previous answer. In this case, you'll see that I still would have gotten 7.82 either way. And so we know the diameter. And notice the diameter is in feet, right? Not square feet. Area would be square feet. But the diameter, that's just a length, so that's just plain feet, right? It's linear units, not square units. Now, what if we just want the sector of a circle, right? So let's get a picture up here. We'll call this circle P because the center is P. Notice we have 2 radii shown there, right? Plural of radius is radii. So one radius is AP, one radius is BP. And then the arc AB. And again, if there's ever a choice of which way to go, use the shorter distance from A to B. Right? Don't take the long way around the circle. Take the short way around the circle. So we're going to set up a proportion again, because I know the ratio of the area of the sector to the area of the whole circle has to be equal to the ratio of the measure of the arc to 360 degrees. Right? So very, very, very similar to what we did before. We're going to set up a proportion and we're going to solve it. Okay, so again, let's try to find an exact answer and then also provide the decimal approximation. So I've got a circle, diameter, the radius is 8 centimeters. And we've got a wedge cut out, 60-degree wedge. I wonder what the area of that sector is, right? It's like a slice of pizza here. So again, this is how I'm going to set it up. Take the area of the sector compared to the area of the circle. That has to be the same ratio as the measure of the arc compared to the measure of the circle. Area of the sector, got no clue. Area of the circle, well, that's going to be pi r squared. Measure of the arc, well, that'll be the measure of arc AB. But the measure of the entire circle, that's almost 360 degrees. So for pi r squared, I can make that pi times 8 squared for this question. The measure of arc AB, well, for this question, that's 60 degrees. So we can do some simplifying here. 8 times 8 makes 64. Reduce the fraction with the degrees cancel out. And so for the area of the sector, it looks like if we just multiply each side by 64 pi, we get 64 pi over 6, which is an exact value, although it will simplify just a wee bit. Right, 32 pi over 3 is my exact answer, and that would be in square centimeters, right? Centimeters would be linear, square centimeters for the area. And then if I grabbed a calculator and punched some buttons, it comes out to be about 33.51 square centimeters. And we need to ride off into the sunset one final time. Unfortunately, instead of pizza, you are provided with a worksheet. Dun, 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 dun. I'm afraid of worksheets go by. We just have one worksheet today, though. And that is our final sunset for the academic school year.